This is the fourth lecture for Text Unit 3. Here we're going to talk about some additional problems in stoichiometry. Let's start off with this example problem. I provided a balanced equation for the reaction of H2SO4, which is in fact sulfuric acid and battery acid, with sodium hydroxide. And the products are sodium sulfate, which you should be able to identify, and water. The question is, how many moles of H2SO4 will react with 15 grams of sodium hydroxide? Alright, in this problem, note what you're being asked for, which is moles of sulfuric acid, and the thing you know about, which is sodium hydroxide. Alright, attempt this before moving on. Alright, here we have the solution. 15 grams of sodium hydroxide is first converted to moles. This is the traditional step 1. And we then use the ratio of coefficients provided by the balanced chemical equation, 1 mole of sulfuric acid or battery acid over 2 moles of sodium hydroxide, to convert to moles of H2SO4. So again, Step 1, grams of sodium hydroxide are converted to moles. Step 2, moles of sodium hydroxide is converted to moles of H2SO4 using the balanced chemical equation. At this point we stop because the question is about moles of H2SO4, and the solution is 0.188. Alright, now attempt the additional question. How many grams of sodium sulfate will be produced? Now this is assuming the same reaction. 15 grams of sodium hydroxide reacts. Attempt this before moving on in the lecture. Right, the solution for this, step 1, looks the same. 15 grams of sodium hydroxide is converted to moles using the molar mass. Step 2, instead of converting to moles of H2SO4, we convert to moles of sodium sulfate using coefficients from the balanced chemical equation. Step 3, using the molar mass of sodium sulfate, we convert from moles of sodium sulfate to grams of sodium sulfate. The solution is 26.6 grams of sodium sulfate. All right, review again. Step 1. Grams of sodium hydroxide are converted to moles using the molar mass. Step 2, convert from moles of sodium hydroxide to the thing we want to know about, moles of sodium sulfate. Step 3, convert from moles of sodium sulfate to grams of sodium sulfate. In this problem and in the last problem, you can review the steps. Grams of sodium hydroxide cancel, leaving moles. Moles of sodium hydroxide cancel, leaving moles of sodium sulfate. Moles of sodium sulfate cancel, leaving grams. All right, check your work on both problems and then moving on. Here's another question. What is the percent yield of the following reaction if 60 grams of calcium carbonate is heated to give 15 grams of calcium oxide? And the reaction is the decomposition of calcium carbonate, which actually happens or can happen upon heating. Alright, you know everything you need to do to solve this problem except the definition of percent yield. Right. So what is that? In the lab, and when you'll look at later semesters, sometimes not all the product of a reaction is obtained. This may happen because the reaction doesn't go completely. This may happen because of some spilling. This may happen because of other accidents. This, by the way, will be a problem in industry in addition to your laboratory. A percent yield shows what fraction of the expected product or percent is obtained. percent yield is defined as the actual yield over the theoretical yield multiplied by 100%. The theoretical yield is the result of a stoichiometry calculation. In other words, this calculation provides the theory or the predicted result. This sort of calculation you already know how to do. Start with what you know about 60 grams of calcium carbonate and convert that to moles using the molar mass. That's step 1. In the next step, we convert to moles of the thing we want to know about, which is calcium oxide. So 1 mole of calcium oxide over 1 mole of calcium carbonate is the factor. This cancels moles of calcium carbonate and leaves moles of calcium oxide. Notice we've already canceled grams of calcium carbonate in step 1. Final step, step 3, we convert to grams of calcium oxide, which is what the question is about. The predicted yield in grams is 34 grams of calcium oxide. The actual yield is what is actually obtained. In a lab, you would find this out by putting the amount of product you obtained on a scale and weighing it. In this problem, it's a given. We're assuming, or you're told, that you put the calcium oxide on a scale and got 15 grams. The percent yield is the actual yield over the theoretical yield multiplied by 100%. Now, the actual yield and the theoretical yield in this case are both expressed in grams. They need to be expressed in the same unit so the gram units cancel. This fraction is then multiplied by 100% to convert it into a percentage. We have two significant figures, so the solution is 44%. All right, you try this. What is the percent yield of H2O if 138 grams of water is produced from the reaction of 16 grams of hydrogen in excess O2? In other words, there's enough O2 present for all the hydrogen to react with. The balanced equation for this reaction is combustion of hydrogen. Hydrogen reacts with oxygen to make water. Provided this information, you should be able to attempt the problem, which you should do before moving on in the presentation. Right. The theoretical yield is a stoichiometry calculation. So start with what you know about, which is 16 grams of H2. Convert to moles using the molar mass. Grams of H2 cancel, leaving moles of H2. This is step 1. In step 2, we convert from moles of H2 to moles of water using the balanced equation. Note this factor has 2 moles of water over 2 moles of H2. The 2's from the balanced equation. Moles of H2 cancel, and we're left with moles of water. In the third step, the molar mass of water is used as a conversion factor, grams over moles, to convert from moles of water to grams. The solution is 143 grams of water. All right, that again is our theoretical yield, or what we expect or predict to get. Percent yield is the actual yield over the theoretical yield times 100%. And again, in this classroom exercise, you are given the actual yield. Note that actual over theoretical, grams cancel. Make sure that the mass units are the same. Multiplied by 100%, the solution is 96.7%. All right, that concludes Lecture 4 for Unit 3.